Welcome back to another episode of Design Patterns. We're going to be looking at the Singleton today, and let's just jump right into it because I think I've already done most of the intro in the first episode. Now, essentially, with a Singleton, all you want to do is make sure there's only a single copy of your class or object ever, and that nobody creates a bunch of it, usually class. Alright, so let's start out by updating our CMake stuff. We're just going to make a new folder. And while I'm doing this, I'll quickly mention that you're totally welcome to make pull requests on the repo. If I get something wrong, add your notes, add your new examples, make corrections. That's all fine and totally expected and wanted. So leaving comments does help, like on the YouTube video, but you never know about YouTube comments. But on GitHub, with a pull request, it can be properly vetted. And as I stated in the first episode, don't expect me to get these 100% perfect. I'm kind of giving my interpretation of them, and sometimes I'm wrong about things. It happens, but that's one of the great things about just jumping in and doing it, is you learn a lot. Whether you do it right or wrong, you end up learning something. So that's also kind of the point of these, is just to learn. Alright, so we made a Singleton folder, we added the subdirectory for Singleton. Let's also just make this CMake. I'm going to just copy this other one from factory and paste it in here, and we'll open it and make sure we get this updated. We're going to start out with just a main, and I guess I'll have probably a singleton.h. That should work, and that'll give us a new executable. But first we got to make these files, and then we should be good to go and start doing some examples. Autocorrect is not helping much today. Alright, I guess it's because the CMake needs regenerated or whatever. But essentially, we can make a singleton in quite a few different ways, and this is kind of a risky pattern, as in you don't necessarily want to use it that much. So if you're using it, usually you have like a really specific reason. Often, for me personally, I like to use it for things that manage other things, because you typically only want one manager, and you want it to just kind of be like automatically created when your program runs, so it doesn't get created by other people, and you might be able to access it and do stuff with it, but you can't just like create managers willy-nilly, and that's generally how I do it. So let's go ahead and make one and make a little demo. Alright, I'm going to make this very generic because I can't think of a great example off the top of my head, but basically we're going to make a class here. We're going to call it, I'm just going to call it manager. It's just going to be a generic manager in our case. Alright, and it's basically going to have a function that we can call like initialize or get. I usually call this initialize or get. So let's spell public correctly. So it'll look something maybe like it'll return itself basically. So manager star, let's just call this a init. And this function is where some magic is going to happen. Hold on, let's make a private area too. So basically we want its own instance to be controlled by itself, but there's nothing yet stopping other people from creating this manager. So to stop other people from creating it, there's a couple different ways you can do this, but one of the most simple ways is to just make the constructor private. That way no one has access to it, and if they try to create it, they'll get a compiler error and it just won't work. So you just put the manager down here, make it private. That's it. And I accidentally keep putting these semicolons at the end of these headers, but it's not required. Alright, so in here, we might just have an instance, and we'll initialize it if someone calls a init. So we'll just go like manager star instance, start it out as null pointer. Oh, this needs all to be static, also rather important. That way it's not recreated anytime they call it init. So if it's something is static in C++, it only gets created once, and that is kind of nice for singletons. You kind of need to work with that. So you'll do if instance. So if it's, well, we could do a not here. You can do it either way, depending on how you want to do your logic. So if not instance, which means if it is not created, then we'll create one. So if it's not null, am I saying that backwards? I'm saying it backwards. Let's not it. Boy, that's a conundrum of a statement. All right. So if the instance exists, all we do is return it. Well, assuming we return it, because this init is going to return it. But maybe we want to call it like get. Let's go with get. I guess you could do it either. This is called the lazy initialization because it doesn't get created until somebody actually calls the get and uses it. And if you call get after it's already initialized, it doesn't do anything but return it. So instance. So if it's already created, we return it. If it's not created, so we'll do else down here. You don't necessarily actually need this else because the way I'm doing this, I'm going about this logic, we want to create it. So we'll go instance equals new manager and then return instance. So yeah, we could make this logic a little more simple, but essentially this will do what you want to do. No one else can create this class. When you call get, it's going to initialize it and return it. And if it's already initialized, it'll just return it. And there you go. There's the very lazy initialization. Let's clean this up a little bit, and let's just do the not case here. And the reason this is nice is, well, it's less lines of code. And at the end, we can just kind of return no matter what. So less return statements, just one at the end. Typically better. And there's a very clean way. So it holds the variable for the instance. If it's not created, then it creates it. Otherwise, this just gets skipped over because it's already created, so it's fine. And it just returns it. And there you go. You got a little Singleton manager. And we could test this out by going, let's try to make one. Manager. Well, we could go star manager even. Now, this is where things get a little interesting because this here will be fine because you can hold references to it. Holding a reference to it isn't making a copy. It's just another pointer that points to the same thing. So that's a little different because this here should compile just fine. Why do I not have exit success here? I don't know. I probably need to just include something. Yeah, standard lib. All right. So if we just hit play here, oh, I'm on the factory one. Let's switch this to our Singleton one, our little Singleton program, all being managed by CMake. It's very nice. All right, and it works fine. No errors. So we could still even go manager equals manager get. Now this doesn't quite work because we don't actually have access to this get function until we instantiate a manager, which is a bit of a conundrum, right? So how do you do that? Well, this isn't quite good enough. This function here also needs to be static, and that way we have access to it without needing to instantiate the manager. Just part of how C++ works a little bit there. And you see we no longer have squigglies. So we can we can make a pointer manager, not set it to anything, not initialize it, and then we can grab the pointer to an instance with this get. And also you can even do away with this entire thing and just call a function from your Singleton. So let's go back to our Singleton real quick because, well, let me think about this real quick. Let's talk about this real quick. So if you do it this way, then you're holding a pointer. So often if you're deep within a function and your function's going to use the manager, maybe somewhere in it, you'll just grab a temporary pointer to it. And just that way you only have to do this get method once because the get is going to do this whole check thing every time. You know, it's a tiny thing, but maybe it'll do a lot more if once you work it up and you have a bigger thing going on. But the thing is, you don't want to necessarily be checking if it's instantiated every single time if you're doing this lazy initialization way, and that's why you would do this. That's why you would make your own pointer and get it just once and then continue on with your function and use it as needed whenever you need it. But there's an even lazier way to do it that's a little less efficient but doesn't usually matter too much, and that's what I was about to talk about. Just wanted to preamble that a little bit, and that's where you would just call this get, returns the pointer to it, and then you call a function from within the manager. So you need some functions from within the manager. So maybe we're storing something. You got to decide what you're managing, what you're doing, and maybe your Singleton even does something else. But let's say we want to just manage, I don't know, let's manage some shipments of tea because that's what I'm drinking. Lipton black tea. Get yours today. Link below. All right, so very quickly, I've just made something for us to manage, and yeah, of course, yours is going to vary depending on what you might be managing with the Singleton. But I've just made a struct called T, and the T has a cost, some ounces, and a quantity. Or I don't know, I'm just kind of making stuff up here. We'll say number bags or something. I don't know. Okay, well, I got some fields. I'm going to change something here. We'll just call it strength because, you know, T's got different strengths. All right, well, Obviously, this is a terrible example. If it were real T, there's like a gazillion fields you want to fill out of what type and all that. But we're just keeping it very simple because we just want something to manage, basically, which is often what managers and middlemen want. They just want something to manage. They don't care if their job's useful. The hardworking people at the low end do all the real stuff. Management just they're kind of like singletons. I'm talking nonsense. Don't take anything from that. All right, so let's include RT. And okay, so we just want to add some public methods here. Like we could have void add, and we'll take a little t right there. So we can add some t, and of course it needs to do something. And maybe we have just like privately a structure of managed t's. So I'm just going to quickly do, I guess, a vector of t, and I'll just call it t's. All right, let's include vector. Yep, you're going to need that if we're using a vector. This is, and maybe we'll have a remove also. And we'll just also take a t. I don't know, this is a bit tricky because they need like unique identifiers to remove them or something. So maybe we need something like that, but I don't want to get into that. That's just getting a little too complicated at this point, I think. I don't know, this is honestly not the greatest example, but hopefully you're getting the point. That's the main thing, is just to have something to code here. All right, so you can call your manager.get, and you can add a new t. So you got to instantiate one. I don't really have one here, so I guess I could just like create one on the fly. And since it's a struct and things are in order, we can just put a cost, a strength, and a quantity. What if we just put some ones in there? Cost of 1, strength of 2, quantity of 3. All right, it doesn't actually like this. Guess we'd have to create it outside of here, like so. Doesn't really like that either. We could put a proper constructor in there, or maybe it'll do it as like an initializer list. But let's not overwork ourselves. Yeah, it should work. I don't know why. I don't know. But it's better if it's very explicit. So you could just fill out your t, cost equals 1, not strength quantity. Okay, guess we do it like that. All right, strength equals 2. All right, so now we have some t, and we can add it. So maybe we have a function or something that kind of does that. And then if you want to remove it, well, you got to have some remove logic, and you got to have some add logic. So you go back to your singleton, go back to this function, and well, let's just keep this super simple, and then let's just go push back on this t. And then it doesn't matter, because for example, if we have this within a scope of its own, kind of like so, obviously this t is going to get destroyed at the end of the scope. But if we've already added it with the manager, now our manager is going to have a copy of it in here, since we called that add. And maybe we want some access to this stuff too through the singleton if we want to check the list, manage it a little bit. The remove, we got to decide, is it a matching t? Which one exactly do we remove? Yeah, and that's going to get a little tricky, so let's skip over that because for sake of example, it's going to make it too complicated, but you're probably getting the point here. So then later, we could get it as well. So maybe we have a function that's like, let's take a look here. Maybe we want to be able to get it. We don't want to be able to mess with this private vector, but maybe we just want to get access to it. So we could do the same thing. We could just have it return a copy of this list with a we already have a get method, so I don't want to redo that one. So maybe we'll just do like a check, I don't know, or get t list or something. Yeah, sure, get t list, that's fine. And it's just going to return our vector. And this will return a copy of your vector, so you can look over it and whatever, but it's not actually gonna, if you modify it, it's not gonna affect this list. So just a way to give access to your private stuff without allowing modification of it. Of course, we could do const, but then people could use const cast and cast that const away. So const doesn't necessarily even const, which is a whole nother rant of mine. I don't even understand the point of const. It literally does nothing when you can use const cast and just ignore it anyway. So just like a whole giant thing they've worked on in the language that doesn't actually do anything. It's kind of funny if you think about it. Maybe there's other points that I don't know, but just a random rant. All right, so now we can call somewhere later in our code, manager get, because we got to get the instance of the manager, and then get t-list, and of course this returns something. So if this is returning something, you want to actually make sure they are doing something with it, because there's no point in calling get T list if you're not doing anything with it. So you probably want to put a no discard qualifier in front of that to make sure they're actually saving the new variable. Because yeah, if you just do this, it returns it, but you're not doing anything with it. So with no discard, it should at least throw a compiler error, which it doesn't for some reason, but it should. Maybe I don't have that on somewhere on my compiler, but essentially what we would want to do is save this T list so that we can go through it later, like for const auto t's and T list. I guess you could even put this like right here, but that's probably going to call this getter a bunch, so it'd be better to just save a copy of it once. I don't know, the compiler will probably figure it out, work fine, but you could save it, or you could put this whole get T list right here and skip all that. Up to you how you want to do it, but this is just an example, so it doesn't matter too much. And then you could say stuff about it. Let's just include IOStream, and I don't know, we'll just see out some stuff. Maybe we'll make a count here real quick just to have some numbers. Thinking how I want to do this. Yeah, count. Yeah, that's just to put numbers in a list. It's for nothing else fancy really. So actually, I'm just going to call this T, and you know, we could format it better. Cost, strength, quantity, and a little new line character at the end. And I don't think I messed up anything too dramatically here, but this is a pretty naive implementation. I just want to see if it actually shows our T as there it goes. We got one T in there. There's its cost, strength, and its quantity, and it's not this one. It's one from the manager. So we could add a bunch of different T's or remove them, and you know what? To have something to check the list anytime we want it, stuff like that. This is, of course, I'll say once again, a very, very naive example because there's no way to really do anything with these. Naturally, you probably wouldn't be able to reduce the quantity and stuff, but this would give a single point of access to it. No one else can make additional managers. And with something like this, you could very carefully control an inventory and not worry about people messing it up, because the only way for them to add and remove from it is for them to get this single manager instance and call your very specific functions that manage it. So that way you'd make your very specific functions that manage it and really battle test them and make sure there's no possibility of error. So this stuff is great for, well, in my opinion, just in general retail and managing stuff that needs to be very carefully taken care of. But this is the lazy method, and there's kind of a little bit of an expanded example so you have an understanding of how to go forward with it, and just a random thing to manage. But you know, this is kind of the most simple, obvious example, and so maybe we'll look at another one. Yeah, and now that I'm thinking about this a little more, this is actually going to have some problems. If you already know what it is, then awesome, you're ahead of the game. But basically, the problem is, all right, so we're returning this instance. So that actually gives people some control over it, because they could just look at the memory and change the memory. It's not exactly easy to do, but it's something that could be done. So it's more likely that we want to do it a little differently. Like, yeah, we have this instance within this get function, but we could also put this instance down here privately and essentially do the same thing, and it will work just the same. Or it should. I may have, let's see, what did we do? Okay, so if you're doing it this way, you're going to need to return a reference. So a little bit of a different here, and you need this to be a star. So this would essentially do the same thing. Let's see if this works. Oh, we're getting a little bit of complaining. Okay, I guess if you're doing it this way, then you don't have to dereference the pointer, since we're getting a reference to it. So it would just be like so. So there we go. And that should work now. Let's see. Oh, we're still getting a fatal error, and it's because it doesn't like having this static private. Maybe if we initialize it, it'll be a little more happy, but I just don't think it likes it. No, it doesn't. And yeah, so I guess in this case, we'd probably have to just keep this non-static down here, and we just still have the static instance, but it's still, you know, there's something a little wonky about this, as you can see. Not actually 100% sure why this is complaining, but basically, I think in some version of C++, they stopped allowing you to put static private members. So I think it just doesn't like having that privately. So I guess in most cases, it's going to make more sense just to have it here. And you can do it either way. You could do it by returning the pointer and taking it here, or by returning the reference and making this a pointer. Either works fine. But, in some examples I read, people were saying you could put the static variable or the static instance as private, but that doesn't seem to be allowed, at least with my compiler. So yours may vary, but it's probably best practice to not have it in the private. So this should generally work pretty well for just keeping your lazy initialization going okay. And if you just stick with this, you're probably not going to notice any real issues with the Singleton. But let's look at a little more. All right, I guess one of the things I should mention about this is one of the problems with it is it's not very friendly to caching. Like, you get this global variable. One point that's good about it is it doesn't get instantiated unless someone is actually using it, so that's good. But it's a global variable, so it's accessible everywhere, and that means it just exists in memory. And if you have a lot of these, it's going to make things really inefficient, and it's going to be like basically bad for concurrency. So that's one of the big downsides of these, and often why it's not used. But I want to talk about at least one other thing here. All right, and this is not the greatest for this example, but basically there's some cool things you can do within this instantiation that kind of make it nice sometimes. So you can kind of control what kind of instance you want. For example, if you have compiler directives, you can put them in here, and you can say different kind of instances you might want. So for Linux, you might want some sort of certain thing, and for Windows, you might want another, or something like that. So that is one point, is you can just have one manager, but you can put, I'm trying to think of a good example here. Yeah, I guess it would be like Win32, do something, but they're all going to be the same in this case because it's just a simple example. But just want to at least point that out, that you can control how it's created based on what is compiling it. This might make more sense for like compiling for whether you're doing it on a phone or whether you're doing it on, I don't know, maybe you're doing something on a game system. So you might want different variants of like file system stuff and things like that, because often file system managers or helpers can be singletons, and sometimes you might want different kinds of file systems created based on what your machine is. So that is something you can do in these as well. And I guess just to point out, we could even make this a little more simple by getting rid of all this logic and just putting it right here and just doing that. That saves us some lines of code, because essentially this only initializes once because it's static. So the very first time we call this, it's going to initialize it and then just return it. And if you call it a second time and beyond, then it's already initialized, so this will get skipped and it's just going to flat return the instance. So this is a little bit cleaner of a way to write it if you're doing it in this way. This is typically the way I do it if I use it. It's just the super clean way, or at least I try to. So let's, for example, just put in some ifs here, because this is how you would do it. Say if Unix, we'll do another little compiler directive, Win32, and that's all we'll support for now. Maybe we should have back in here too, but you get the point. You can chain as much as you want, because you can have different ones here. And you can see my IDE here actually highlights the one that's getting used. So you could put one of these for your different possibilities of what it might need to do based on some compiler directives. So that's a cool thing you can do with this instantiation. People usually call this something like instance rather than get, but you do what you want. I'm gonna change it to instance. I think that's just going to be easier to understand. And now you can see, of course, that these are redundant because they do the exact same thing. But if they aren't, then you should probably do it. Also, people tend to use these for loggers, sound managers, just stuff like that. Anything you don't want created multiple times, and if you want it to be globally accessible. And this also might be something you only do in debug if it's like a logger, because when you actually push out the release, you want it to be super fast, and you don't necessarily need to be logging the release. That way it's just a little more CPU friendly and can run faster. And it's also worth noting that you can subclass these. For example, we might have a very base one that we don't really use, and then we have one that's like, I don't know what to name it, but you can have it inherit from it, and it still has most of these functions, and it will still have this instance that you can get from this one. And yeah, that's just something you can do, is you can subclass them and kind of work with that system too, which can come in handy. All right, I almost forgot about this one other thing that you can do, and it's basically if you just want to make sure people only instantiate one of your class, so it's still a singleton technically, but you kind of give it, it's just a different way of doing it without having to do this. And you can have like a boolean here to say whether it's initialized or instantiated, and set it to false to start. So what you can do is you can take this up here, get rid of this whole thing, and just go like so, and just have like instantiated equals true. But you can also say if instantiated already, you can like throw an error. So maybe you just want to use assert or something like that, or assert. I guess it would be assert not instantiated. I don't have assert header, but with something like this, if the first one will work fine, but as soon as they try to instantiate a second one, it's going to throw an error. So you want to make sure they destruct the first one first by having a destructor be like instantiated equals false. So you could do it in this sort of way as well. But the tricky thing about this is obviously this is going to get created per class. So you need this outside of it. And you probably want to have, yeah, we're all in a header here. So this is pretty awful looking. But if this were the object file, a CPP, and not a header file, it would look something like this. So we have this one boolean called instantiated. And we started out as false. If they instantiate it, we set it to true, and it's going to crash if they try to instantiate it and it's still true. And then whenever they destruct the class, it's going to set it back to false so that they can instantiate again. So this would be another way that you could allow people to only create one. And of course, you wouldn't have to do this whole instance thing. You would literally just instantiate one. But then again, another thing with this is obviously this is no longer a static singleton copy, so you'd have to take this and also put it up here globally. I think this one personally looks a little bit messier, but you can kind of see the point, because if they want access to these functions, they got to instantiate it, and this, since this is global, they're still working with the same managed info, same thing here. And since it's static up here, there's really no way to access it otherwise, because if you try to access these static variables from outside, you just can't. You would have to do them extern non-static otherwise, but that's a whole nother thing. So that's just another way of doing it that I thought I'd point out, because maybe it's relevant to some people, but just another way to make sure only one of your class gets instantiated. I personally don't use this way, but I thought I'd at least mention it here in the end. And there's probably stuff I'm missing or leaving out, so feel free to leave comments, make pull requests, and add more. The only thing I do request, if you make a pull request, just leave some good comments within the code so people know what they're looking at, because if they watch the video and it's not mentioned, they'll be confused. All right, that's it. Yeah, I think that's it. I think that's all I'm going to talk about with this one. You probably get the point. The main thing is just kind of understanding how to do this, and understanding what it's good for, when it's not good for. And if you have any more examples or comments, feel free to leave a comment. And if you think I royally messed something up, you're welcome to make a pull request and leave some explanations there. Comments are always good. So that's going to be it for this episode. Huge shout out to the patrons and all the people that help support and make these episodes possible. And I'll see you in the next one. Peace.